The American Bridge Division of United States Steel presents the Columbia Seafirst Center. It dominates the Seattle skyline, this building that began its life on an architect's drawing board as a modest 35-story structure, but grew to 76 floors by the time the planners had completed their work. Seattleites had seen nothing like it, nor had other Westerners for that matter. At 76 floors, it's the tallest building west of Chicago and the 10th tallest in the world. It's a tribute to modern engineering and construction techniques. With a facade of mostly glass and aluminum, Columbia Seafirst Center is one of the lightest buildings for its size anywhere. The building rises 943 feet above 4th Avenue. It can be snowing at the top and raining at the bottom. Seattle has had an interesting growth skyward. The city's first high-rise office building was the Smith Tower, built in 1914. It was 42 floors tall. The Smith Tower remained Seattle's tallest for nearly 50 years, until the Space Needle took that honor in the World's Fair year of 1962. The Needle stands 605 feet tall. 7 years after the World's Fair, the Seafirst building's 50 floors surpassed the Space Needle's height by 4 feet. Because of changes in the building code, the Columbia Seafirst Center should remain Seattle's tallest. Oddly enough, developer Martin Seelig did not set out to build Seattle's tallest structure. Initial plans were for 35 floors. Later, Seelig acquired additional land on the site and upped the plans to 60 floors. By the time excavation began, the design had reached 76 floors by making use of height bonus rules that provide additional floors as a reward for public facilities and shops. The excavation eventually reached a depth of 120 feet. For comparison, most high-rise excavations are 40 to 70 feet deep. The workers had to remove more than 250,000 yards of earth from the site. 120-foot tie-back shoring walls were far beyond heights achieved ever before in the United States. From a construction standpoint, the foundation and shoring system were among the most difficult challenges in the building's design. The results were award-winning. The design included an innovative tie-back anchor system in which the building anchors were drilled into the soil located behind the shoring walls. A steel rod was placed in each drilled hole, which then was backfilled with concrete. The completed shoring wall had 1,500 tiebacks, each with a holding capacity of about 200,000 pounds. Columbia Seafirst Center's first elevator transported workers down to the job that included 3 major footings for the building. The footings are the basis for Columbia Seafirst Center's 3 main structural columns. These footings are 50 feet long, 50 feet wide, and 10 feet deep. Each footing required 1,800 cubic yards of high-strength concrete. During the early stages of construction, portable cranes were used for material lifts. The building's design calls for 6 below-grade parking levels. 3 construction cranes were set into place early in May of 1983. These tower cranes, which performed the heavy lifting of equipment and materials, later would move upward right along with the building. When the tower cranes were ready to operate, the mobile cranes were hoisted out of the excavation, and the stage was set for a milestone in Columbia Seafirst Center's life, the first piece of structural steel. Owner Martin Seelig was among those who signed the building's initial steel beam. Before the construction work ended, 27,000 pieces of structural steel were handled by the cranes. May 18, 1983, and Columbia Center's first column is in place. Shortly after the first steel placement, the framework began to take shape. Shop drawings for the building's steel fabrication had taken 150 detailers 6 months to prepare. The structural steel was rolled in Japan, fabricated in Korea, and was delivered to Seattle at Piers 20, 28, and 115. Working a tight time schedule, trucks took the steel to the job site. A constant demand for crane time by every construction trade made scheduling critical. By late June of 1983, just a little over a month after steel erection had started, the building framework reached the 4th Avenue level. The giant erector set had 76 floors to go. By midsummer of 1983, the steelwork had reached the 5th Avenue level, and it was beginning to look like a building. After another 6 months of construction work, the structure looked like this. It was January of 1984, and 27 floors had been framed by the ironworkers. By then, people from other trades were busy on lower floors. This scene was recorded in May of 1984. The superstructure had risen to 55 floors. When completed, Columbia Center had 16,000 tons of steel, and the building weighed about 14 pounds per square foot. But that's light compared to the 50 pounds per square foot for the neighboring Seafirst building. The steel was supplied and erected under a contract with American Bridge, a division of United States Steel Corporation. American Bridge also installed and operated the tower cranes. Those cranes atop the building had to move higher as the building rose skyward. Note the relationship of the crane's cab to the top horizontal steel beams. The crane was jumped 6 floors every time it was raised. Though it moved almost too slowly to see, the crane tower inched higher and higher. The crane was literally lifting itself upward. Later, ironworkers would build the framework up to the crane, and it would pull itself up another 6 floors. That routine would be followed until the framework was completed. The crane tower's upward progress was checked constantly to make sure it was plumb. The relationship between the crane cab and the building's top horizontal beam is now quite different. The cab is 6 floors above the spot from which its upward movement began. It was an operation watched even by building owner Martin Seelig and his son. The name American Bridge dates back to 1900 when the company was formed. However, its construction and engineering expertise began even earlier than that, when its predecessor companies were creating the American phenomenon, the skyscraper. American Bridge has erected most of the nation's truly notable buildings, including Chicago's Sears Tower, New Orleans Superdome, and now Seattle's Columbia Seafirst Center. Know-how in handling large assemblies in confined areas, in lifting record-breaking weights, in how to get the job done. That's all part of what you get when you contract with American Bridge. Ironworkers were the construction stars. Heights don't seem to bother them, but balance is a job prerequisite. One of the Columbia Center ironworkers was Ron Howard, a former pro football player. Howard had been a tight end for the Dallas Cowboys and the Seattle Seahawks. He's more careful atop a beam than he was on a football field.
You have to respect death. You have to respect your work every day. Otherwise, all it takes is one small mistake. Each day, it's like getting up for a game. I pretty much keep the same type of positive attitude. I have to get myself mentally prepared to climb a climb or get up on one of these beams every day, and it's a lot more exciting being up here.
If Columbia Seafirst Center's structural steel beams were laid end to end, they would stretch 75 miles. The beams were connected with 209,000 high-strength bolts and 90,000 pounds of welding wire. While the steelworkers were reaching for the sky, other construction people were on a variety of lower floors. 2 construction elevators, called hoists, were in constant operation, taking workers and material to their jobs. Here's the view the construction workers had as they rode the hoist. This lift carried only people. The second hoist carried materials. The hoists went up the tower at 800 feet a minute and descended at a little over twice that speed. One of the critical materials in the structure is high-strength concrete. A special hoist was used to deliver the concrete to each floor. On floor after floor, the action was repeated. Steel reinforcement bars were interlaced over a metal base. Columbia Center contains 7 million pounds of rebar. If the rebar were placed on a freeway, it would reach from Seattle to Sacramento, California. Columbia Seafirst Center was designed to transit the weight of the building and its contents to the foundation through 3 main columns of concrete and steel. This is a concrete pour for one of the composite columns. The steel column is surrounded by vertical rebars and horizontal welded wire mats. Buildings do sway slightly, but dampers were bolted to the Columbia Center's steel arches in 260 places to lessen the movement. Steel on each floor got a fire retardant coating. Obviously, steel beams won't burn, but heat can weaken steel. This material retards heat should there be a fire. A 76-floor building obviously presented some interesting challenges in heating and cooling. The mechanical system in the Columbia Seafirst Center differs from other buildings in that water circulates to the heat pumps for heating and cooling through the piping system for the fire sprinkler system on each floor. 94,000 gallons of water circulate through the hydronic veins and arteries of this massive structure at a rate of 25,000 gallons per minute. There are 30,000 sprinkler heads in the building. In a fire mode, the heating and cooling functions automatically cease and water is fed to the fire system. The building's ceiling space contains 2,000 heat pumps for heating and cooling. The average floor has 28 of these heat pumps to control various office temperatures. This is one of the building's 6 giant cooling towers which help control the hydronic system's water temperature. Each 40-foot-long tower weighs approximately 25,000 pounds. The 6 towers were completely fabricated off-site, and each was delivered to Columbia Seafirst Center as an assembled unit. This saved the general contractor considerable hoisting time and shortened the overall construction time. The mechanical system is operated through this control room. Excess heat generated in one part of the building is transferred automatically to another part with deficient heat. It's a computer-controlled system that is energy efficient. The domestic water system is fed through a separate network of pipes. Workmen here are installing a prefabricated restroom. Most of the domestic water piping is copper. Columbia Seafirst Center requires as much electrical energy as would a town of more than 2,000 people. This room is one of 3 transformer vaults in the building. The vaults are connected by this 15,000-volt cable. It's the main artery of Columbia Seafirst Center's electrical system. The 4-inch diameter cable is carefully lowered through conduits in the building's core. Should a power outage occur, 2 diesel generators will provide electricity to all life safety equipment. The building has more than 600 miles of wire, 8,000 electrical outlets, and 15,000 lighting fixtures. August 7th, 1984 was a milestone for the Columbia Seafirst Center. Hod carriers and businessmen alike signed the final piece of structural steel before it was set into place. It was a banner day for developer Martin Seelig, his family, and his staff, and for the iron workers who had chalked up an enviable safety record on this job. Not quite 15 months from the day the first piece of steel was lowered into the site excavation, the final piece was bolted into place. One of the ironworkers wore his version of a tuxedo for the occasion. A huge 50 by 100-foot flag was placed on the building's west side as part of the final steel ceremony. The building's outer shell is aluminum and glass, a charcoal or dark gray color. Corners of the structure are cantilevered, providing corner offices free of view-blocking vertical columns. The frame for the outer shell is firmly attached to the structural steel. Columbia Seafirst Center has 8,816 windows, enough to cover 11 football fields. The lobby glass is impressive in appearance and dimension. Built without view-obstructing metal frames, this curtain of glass stands 4 stories high and cost approximately $1 million. Granite quarried in South Dakota added a distinctive touch to the building. Polished granite walls were installed on floors 1 through 5, the 5th Avenue lobby, and the 40th floor sky lobby. Granite flooring was installed in the 5th Avenue lobby and plaza. The public shops and facilities are located in the arcades. The building has 58,000 square feet of retail space. Seattle's building codes give developers height bonuses for adding public amenities such as plazas and stores. This is part of the area that enabled Columbia Seafirst Center to reach 76 floors. There are 46 elevators with custom-designed cabs.
Please stand clear of the closing doors.
These are talking elevators.
Sky lobby, floor 40.
In addition to talking, the elevator provides information on a small screen. The West Coast's tallest building is a conversation piece in itself, and developer Selig made sure the conversation would be lively by purchasing a standing mobile by the late Alexander Calder as the building's art object. It was an $850,000 addition. The Columbia Seafirst Center was truly a challenge to each person and firm connected with it. It was not just another building. It was a project that brought out the best in the design and construction industry. And for years, it will remain the West Coast's premier building.
just weren't flying today. You're on the big cliff. You're on TV. You got sound, Kenny?
Yeah.
You got sound on them?
Sure do.
Oh, God.
How we doing, Paul?
Well, we haven't said anything out of the ordinary yet.
We're doing fantastic. I think we ought to add 5 more floors. This view is just better the higher you get.
No, it's a hell of a view up here.
Unbelievable.
About as good a view as you can get, huh, Kurt?
I never had a better one.